Welcome to my YouTube channel Cognara. I'm Michael, your science and technology educator. Today, we are going to explore one of the strangest and most mysterious places in the universe, a place where the laws of physics bend, time behaves in unfamiliar ways, and our understanding of reality itself begins to break down. We are going to talk about what really happens inside a black hole, not as science fiction, but as far as modern science can honestly take us. When most people imagine a black hole, they picture a dark cosmic monster that pulls everything in and crushes it into nothingness. That image feels dramatic, but the real story is quieter, stranger, and far more subtle than movies ever suggest. To understand what happens inside a black hole, we first need to understand what a black hole actually is. A black hole forms when a massive star runs out of fuel and collapses under its own gravity. The matter inside the star is squeezed into an incredibly small space, and gravity becomes so strong that not even light can escape. The boundary around a black hole is called the event horizon. This is the point of no return. Once anything crosses this invisible boundary, it can never come back out, no matter how fast it moves or how powerful its engines might be. From far away, a black hole does not look like a hole at all. It looks like an extremely heavy object, bending the space around it. Stars can orbit it, gas can swirl around it, and light can curve as it passes nearby. In many ways, a black hole behaves like any other object with gravity, just taken to an extreme. Now imagine you are approaching one. From your own point of view, nothing feels unusual at first. You do not suddenly feel stretched or crushed. You do not feel a violent pull. Space feels calm. Gravity feels gentle. But something very strange is happening to time. To an observer watching you from far away, you appear to slow down as you get closer to the event horizon. Your movements become slower and slower, as if you are stuck in slow motion. Your image begins to fade and redden, as the light you emit loses energy trying to climb out of the black hole's gravity. From their perspective, you never actually cross the event horizon. You just appear to freeze there forever. But from your own perspective, none of that happens. You fall straight through the event horizon without noticing anything special at that exact moment. There is no sudden barrier. No visible line. No dramatic change. Space and time still feel normal, at least for a short while. This difference in perception is one of the most unsettling features of black holes. Time itself behaves differently depending on where you are standing. As you continue falling inward, gravity begins to change more rapidly across your body. Your feet are slightly closer to the center than your head, which means gravity pulls more strongly on your feet than on your head. This difference grows larger the deeper you fall. Eventually, it becomes extreme. Your body is stretched vertically and squeezed horizontally, like a strand of spaghetti being pulled apart. Physicists actually call this process spaghettification, not as a joke, but because it describes the shape your body would take. Your atoms are pulled away from each other. Your molecules are torn apart. Your body is no longer a body in any recognizable sense. This is not something you feel in advance. It happens too quickly and too violently for your brain to process pain. Now, if the black hole is very small, this stretching happens before you even reach the event horizon. You would be destroyed outside the black hole itself. But if the black hole is very large, like the supermassive ones at the centers of galaxies, you can pass through the event horizon before any serious stretching begins. In that case, you would fall calmly for a while inside the black hole. And this is where science becomes deeply uncertain. Inside the event horizon, all paths lead inward. There is no direction that points outward anymore. Moving forward in time means moving deeper into the black hole. Eventually, according to classical physics, everything reaches a point called the singularity. The singularity is where all the mass of the black hole is compressed into a region of zero size and infinite density. At this point, gravity becomes infinitely strong, and space and time as we understand them stop making sense. Our equations break down here. Physics no longer has reliable answers. We do not know what truly exists at the singularity. Some theories suggest it is a real physical point. Others suggest it is a sign that our current understanding of gravity is incomplete. There is also another strange illusion involving time. From the outside, it looks like you freeze at the event horizon and never fall in. From the inside, you cross it and reach the singularity in a finite amount of time. Both perspectives are correct. Time itself splits into different realities depending on who is observing whom. This leads to one of the deepest questions in physics. Where does information go when it falls into a black hole? If your body, your memories, and all the information that makes you fall into a black hole, does that information disappear forever? For a long time, physicists thought the answer might be yes. But that created a serious problem. The laws of physics say that information cannot be destroyed. This puzzle is called the black hole information paradox. Some modern theories suggest that information is somehow stored on the surface of the event horizon itself, like a cosmic memory etched into space. Others suggest it is released slowly as the black hole evaporates over enormous periods of time through a process called Hawking radiation. Stephen Hawking showed that black holes are not completely black. They slowly lose energy and shrink over trillions of years, eventually disappearing. What happens to everything that fell in during that time is still one of the biggest unsolved mysteries in science. Now comes an even deeper layer of uncertainty. Quantum physics and general relativity, our two best theories of reality, disagree violently about what happens at the center of a black hole. Some ideas suggest that the singularity might be replaced by something else, like a bounce into another universe, or a tunnel into another region of spacetime. Others suggest that spacetime itself becomes something completely different, something we do not yet have language to describe. At this point, honest science has to admit something uncomfortable. We do not know what truly happens inside a black hole. We know what our equations predict. We know what our instruments observe from the outside. But we do not yet have a complete theory that can describe the inside with confidence. And that is what makes black holes so important. They are not just cosmic monsters. They are natural laboratories where gravity, time, space, and quantum physics collide. They are places where our understanding of reality reaches its limits. In a strange way, black holes are not only about destruction. They are about knowledge. They are telling us that the universe is deeper, stranger, and more subtle than our current ideas can fully explain. They are showing us that time is not absolute, that space is not fixed, and that reality is far more flexible than our everyday experience suggests. So what really happens inside a black hole? We know that matter is stretched, time behaves strangely, and everything falls inward towards something we cannot yet describe. Beyond that, the truth is still hidden behind the edge of our knowledge. And perhaps that is the most honest answer science can give right now. Not certainty, not fantasy, but humility. If this exploration changed how you think about black holes and the nature of reality, Share your thoughts in the comments. And for more calm, thoughtful, and deeply human explorations of science, technology, and the future, subscribe to Cognara. I'm Michael, your science and technology educator. And I'll see you again, here on the Cognara YouTube channel.